Okay. All right. So the last half of the course is, as I said, more inferential. It's more SPSS heavy, and we're starting that tonight. But the first thing I want to talk about a little bit before we get there is the APA write-ups. Yes, I am. Thank you. But keep asking me those questions. So the APA write-ups, this is the way you present your findings. And there are 4 assignments. You have to write up APA assignments for different kinds of procedures. And the first kind of procedure you're assigned to write an APA write-up on is correlation. And I want to talk about the APA part of that first because we've already talked about correlation. So theoretically, you know what I'm going to talk about when I go through an example. If you look on the D2L site under Content, there's a folder that says APA examples or APA write-up examples or something like that, and there are 3 of them. And the 3 correspond to 3 of the 4 assignments. The first one, I'm not sure what the order is, but I think it's the first one, is the APA for correlation. There's an APA for t-test. There's an APA for ANOVA. You're going to find out what those are eventually. But we already know what the correlation is. So I've got my correlation. I know R is some value. I know whether it's significant or not. How do I say that's what it means? So if you look at the APA write-up example for correlation, I've got 2 pages. And the first page is very short, sweet, to the point. It's a simple correlation between just 2 variables. Now you also remember though that when we did correlations, sometimes we had a bunch of variables and we correlated everything with everything. Well, that's what the second page looks like. So when you write up a correlation, you can use any example that we've gone over, or you can come up with your own example. You can use any example from Whit and Whit. You can use any example from Green and Salkin, except for the one that this is an example of. You can't do this one. So I've given you several pieces of information here. I've given you the research question, and I've given you the null hypothesis. The research question is there a significant correlation between ACT and SAT scores of freshmen attending a particular university? Notice what I did not say. I did not say, is there a correlation? I can answer that. Yeah, there's a correlation. Hey, it might be 0, but that's still a correlation. But what I want to know is the correlation, is it significant? I'm big on the word significant. So is there a significant correlation between ACT and SAT? So the way you write up a research question involving correlation is essentially, is there a significant correlation between X and Y? Now the corresponding null hypothesis is going to, in most cases, now there are some examples when we get into the single sample t-test, I'll give you another example later maybe. In most cases, the null hypothesis sounds almost exactly like the research question, except that it's a statement and it's a negative statement. So the null hypothesis in this case, there is not a significant correlation between ACT and SAT. The structure of the wording is very much the same, except you say it's a statement, it's a not statement. I was asked to repeat that. The null hypothesis sounds a lot like the research question. Matter of fact, it sounds exactly like the research question, except that it's a statement, not a question, and it's negative. It's the opposite of. So I threw the not in there. There is not a significant correlation. So you'll see on the example at the top of that first page for the correlation write-up, you'll see the research question and the null hypothesis. Okay, so for this we have only 2 variables. Not a big deal. Feel free to use these exact words and just change the numbers and the names inside of the paragraph. Now, I don't want you to write up a write-up looking at the correlation of ACT and SAT scores, because that's the example we've got here. But again, any correlation that we've done, or that you found elsewhere, anything in either of the Green and Salkin examples, we used 2. We got, I think, 2 or 3 from there. and at least one from the Whit and Whit textbook. So you've got a couple of options you can do. I will ask you if, let me just say this up front, if you're working closely with someone, don't do the same examples. I encourage you to work together, learn from each other, study together. I mean, you go over things together, but give me different write-ups. Okay, so here's how it sounds. A Pearson correlation coefficient was computed to test the relationship between the ACT scores and SAT scores of college freshmen attending WXYZ University. That's just a statement of what you're doing, the correlation between the variables and a little more information about it. The results of the analysis reveal a strong positive relationship. Now, with some risk, I'm going to try to write on the screen again, because we saw what happened last time. That went so well. A strong positive relationship. Notice I report the means and standard deviation of each of my variables. I've got the mean and standard deviation for the ACT. I've got the mean and standard deviation for the SAT, ACT and SAT. Again, remember, and we've done numerous examples of these kind of comparisons, the scores are on different scales. It is statistically significant. I knew it. The p-value don't we have to do what to know? Nope, this is a correlation, not a z-score. Oops. Hang on, I lost my file. Okay, back up. Maybe writing on this is not a good example or a good idea. All right, strong positive, statistically significant. The p-value is 0.02. We reject the null. Everything I've underlined says the same thing. Well, first of all, it's positive because my p-value is positive. But it's strong because the p-value is less than 0.05. And if it's less than 0.05, that's when you reject the null. And the last sentence is just plain old plain English what that means. In general, the results suggest that students with high ACT scores also tend to have high SAT scores. If you're high in one, you tend to be high in the other. Not absolutely, but in general. Likewise, if you're low in one, you're low in the other, but we tend to talk about things on the high side of things. The question was which were we allowed to use. There's a couple examples that we went over in Green and Salcombe. That's the one where you have the data sets for. And yes, you may use those. Yeah, use anything we've gone over in class or anything you did for homework. Any example from Whit and Whit, or the homework question from Whit and Whit would be a fair write-up too. Now, what if we had said we had found something like p is equal to negative 0.24? Well, first of all, it would be negative because my number is negative, and it would be weak because it's bigger than 0.05. Well, I've got something wrong here. Yeah, hang on. I'm gonna let that be the p-value, but I'm gonna say something like r is equal to 0.41. But I don't care what R is, I care what P is. I'm sorry, negative. Let's say R is negative 0.41. It's going to be negative because 0.41 is negative. Whether it's positive or negative, where I've written negative in there, that's the value of R. P is always going to be positive. Sorry about that. P is always positive because P is a probability. You don't have a negative probability. It's R that you get the positive or negative from, yes. But it's the P value that you get either the strong or the weak from. And it's weak because, as you said, it's weak because P is not less than 0.05. If we say there's something significant here, we've got a 24% chance of being wrong. And that's too much of a chance for me to be okay with. I want less than a 5% chance of being wrong in saying that. If this were the case, it would be a statistically non-significant, or you can say not statistically significant. You would not reject the null hypothesis. And if you're high in one, you don't tend to be high in the other. Or let's say it this way. I'm going to soften my language a little bit. If you're high in one, you're not necessarily likely to be high in the other. Sometimes I have to be careful, even in my own writing, not making so many absolutely strong statements. Because it may be the case if you're high in one, you're high in the other, but I don't know if that's necessarily true. So if you've got a negative correlation, you would write along with the words I've put in red there. Kind of make sense? Okay. Now you can write up a correlation like this with just two variables if you want to. If you want to be ambitious, let's look at the next page. In the next page, there we go. In the next page, I've got more than just two variables. Let's look at the questions and null hypotheses there. Are there any significant correlations between not just SAT and ACT, but also high school GPA, leadership inventory scores of the students attending that university? So I've got instead of just two variables, I've got four variables. Oh, I need to point out one more thing too that I've not said. Let me go back and point out the number right here. Apologize for this. 454. That's the degrees of freedom, which means it's not it's not the number of pairs. It's the number of pairs minus 1. Now, when you get a number that size, it's not going to change the results much, but technically that's the degrees of freedom. Okay. So if you got several, in this case 4, so are there significant correlations between SAT scores, ACT scores, high school GPA, and leadership inventory scores of freshmen attending this university? My null would be there are no significant correlations between same words. A Pearson correlation coefficient was computed to test the bivariate correlation. I probably should say correlations because you got more than one pair. Okay. Among the 4 variables in the study, and I name what the 4 variables are. The results of the analysis revealed a strong relationship between 2 of them, and I name what they are. They're SAT and ACT to high school GPA. And a weak positive relationship between the other pair. And I've got a table I'll scroll down to in just a second. As a result of the analysis, because 2 were strong, we reject 2 of the apple. And I just kind of made up the numbers here. It doesn't matter. And the others, I had 6 altogether. You'll see that in a second. They were not rejected. You can use the word retained or not rejected. I tend to gravitate toward not rejected. Yeah, I think it's more consistent with if we get the other kind of findings out of it. Yeah. So in general, again, plain English, we somewhere toward the end we're going to say plain English what things mean. In general, the results suggest that students with high ACT scores tend to have high SAT scores, and students with high ACT scores tend to have high school GPAs. All the other variables demonstrate weaker relationships. Okay. Look at my table there. Notice part of the table is blank. Why is it okay for this stuff to be blank? And the answer is because it is redundant information. I don't need high school GPA and ACT right here because I've got high school GPA and ACT right here. Remember that diagonal, and you kind of have mirror images on the lower left and the upper right? Well, I'm just going to put in what we refer to as the lower triangle. And I'm putting in 2 pieces of information between every pair I've come up with, and that's the R value, that's the correlation number itself, so ACT and SAT is a 0.75, and my p-value is less than 0.001. Remember that the p-value is never 0, even though it'll tell you 0 on the SPSS output sometimes. That's because it only has 3 decimal points to use, so it's smaller than the number of places it can use. So we never say 0. If it says 0, you're going to put less than 0.001. Otherwise, you're going to put what the number is right here on our, like we've done on our high school GPA and SAT, where I'm scrolling in front of. So for SAT and high school GPA, my R value is 0.11, but the p-value is not less than 0.05, so that's not one of the significant pairs we found. That's not one of the nulls that we rejected. Now, I said we had 6 nulls. Look, I've got 1, 2, 3, 4, 5, 6 entries here. SPS, I should have put one of those pieces in. I probably should have put a little asterisk saying, with the bottom saying it's significant, but SPSS will actually give you that if you tell it to flag those, and it does it by default. I probably should have indicated by an asterisk or a footnote or something which ones were significant. I mean, you can tell because they're these two, the 0.75 and 0.70, because my number in parentheses is less than 0.05. Yeah, probably so. So I probably would say something like, and this will not say, but I'll show you what I mean by this, though. Like that. What SPS will do, it'll give you a 1 star if it's significant at the 0.05 level. It'll give you 2 if it's significant at the 0.01 level. But I'm happy to just say it's significant. So I've got 2 that are significant. Remember we said 2 were significant in the paragraph. So if you want to write up, we had a couple examples. I know we had one, I think at least one in the Green and Salkin book that had more than 2 variables. That's a good one, right? It's a little more ambitious. If you do that, I may give some difficulty points, like when you try more difficult dive in the Olympics. I'll not let the fact that you tried a more complex example hurt you, in that there's more places to mess up on. The question was, if you do both and you mess up the harder one, you get full points. Just give me one. Don't make me think about that. You decide what to do. And again, most of these things, unless you just really don't follow the format, or you maybe interpret something incorrectly, if you don't get full, they're going to be mostly little 2-point love taps, or usually not more than 5 if you've done most things correctly. If you just don't follow this at all, there's not much I can find there. And quite honestly, I've had people not follow the templates. They just kind of write things in totally different ways with information that may not even be there sometimes. And these are they are templates. The main thing that you need to include, it doesn't have to be exactly like this, but I want the means and standard deviations. I'll just look at the first example. The means and standard deviations of the variables. I want this sentence in there somewhere. That's the core of it. You're safe to use this paragraph and just change the names of the variables and the numbers. Yes. You don't need to reinvent the wheel. Yeah. Don't make up your own statistics. There's a body of knowledge that is quite useful. We just need to learn something about it. Yeah. Okay. All right. Any other questions about the ACT the correlation write-up? Of the APA example, and we'll go over a different example of each of the three kinds I give you examples for. But again, there are three things specified, and the fourth one you choose whatever you want to. You can write up a chi-square, which is the last example kind of procedure we do, and I don't require that. I thought about requiring that for the fourth one. Or you can do a second correlation, or a second t-test, or a second ANOVA. Question is asked: would you like to submit our SPS printout as well? And the answer is no. If it's a problem I'm already familiar with, like any from the textbook, don't do that. If it's from data you get, say at your work, because you think it would be useful, yeah, I'd like to see that. So the answer is it depends. But that's what it depends on. Any other questions? Did that answer your question? The question was how large do you want the data to be? Are you talking about using your own example? If you would get probably 15 to 20 pair, that'd be okay. It doesn't have to be huge. If you use any examples out of the WIT book, they're not going to be huge. Again, because those are designed to be cranked out by hand, which I'm just too lazy to do that. Yeah. I think they're oh, if you want to do a larger set, that's fine. I mean, if you've got math and English ACT scores from your school district, okay, that's fine. But in those cases, if you do an example that is beyond the scope of this class, yes, I do want to see the SPSS printouts. MOUSE, yes, too many acronyms. Education is alphabet soup. They're worse than like Presbyterians, Any other questions?